Hello everyone, welcome back to your favorite channel Studlins, which adds excellence to your learning.
In our previous lecture, we have seen what is sorting and some of the criteria which needs to be used while using a sorting algorithm. To carry forward our discussion, in this lecture, we are going to start with the bubble sort technique. In this technique, we compare the adjacent elements, and if the value is greater, then it is shifted forward. Like we have an array as we can see on the screen, and now we want to sort it. So we will first start by comparing the adjacent elements. If it is greater, then it will be shifted. This will be carried forward till the time we have not reached to the last of the list. Once we have performed this one time, then we are going to get the largest element at the end of the list. And again, when we have done this task at the second last position, we are going to get the second largest element in the list. So from the above two, we can say that at the kth pass, we are going to get the kth largest element of the list. And looking more into it, you can see that we are having 5 elements, then we need to perform 4 passes to sort the list. So in general form, we can say that if we have the n elements, we have n minus 1 passes to be performed for some task. But as we have already sorted the largest element in the first pass, then we are not required to compare with the element in our next pass. So with each pass, our one comparison will be decreased. So this can be done. We are also going to see how to achieve this task. We are also going to see, is bubble sort an adaptive and stable algorithm or not? Now let's move to our live coding window and see how this can be done.
So welcome back students again to this live coding window. So in this lecture, we are going to see about the sorting techniques. So in our first intro video, we have seen that whenever we are sorting any array, so we are keeping some of the points in our mind that what are the number of comparisons we are doing. Then second point which we keep in our mind is number of swaps which we need to do while doing the comparison. The third point which we are seeing that the given algorithm is stable or not. The fourth point which we see that is the particular algorithm or the technique is adaptive or not. And the last one which we are seeing is that is my algorithm is taking some extra memory or not, because whenever we talk about the data structure, we always know that the given particular technique will be our feasible one if it is not consuming any extra memory. Like for example, we are performing any task, but if we are taking the extra memory and the same task can be performed without taking the extra memory, so I think we are going for that approach which is going to take the less memory. So in this we are going to start with the bubble sort. तो अब ये bubble sort होता क्या है? So you can see here that I have an array and in which I have the elements at 8, 5, 7, 3 and 2. So in the bubble sort what happens? We take our first pointer here I and the second pointer here as in j. And then what we see that if we compare this 8 and 5, and if this so let me write here vertically 8, 5, 7, 3 and 2. So we see that the 5 is less than 8. So I am going to swap it, and now my output will be something like 8, 5, 8, 7 and 3. Now my I will again be changed, and now my j will also be changed. Now my I will be pointing to this and my j will be pointing to this. Now you can see here that it is again smaller. So in the next in our next output, our output will be something like 5, 7, 8, 3 and 2. And in the same manner again we are going to compare. Then we are going to have as 5, 7, 3, 8 and 2, and then for the next one I am going to have 8, 7, 3, 2 and 8. So you can see here that after each comparison you can see here that at last I am going to have 8, which is the largest element inside the list, is being sorted at the last of its position. Means we can see that whenever we are performing a bubble sort, so after each pass, we can say that we are going to get the kth largest element. So after the first pass, I'm going to have the first largest element. Once again, if I'm going to perform the pass, so this time I'll be performing my pass on 5, 7, 3, 2 and 8. So this time again I'll start comparing. So you can see here that this position is not going to change because 5 is already smaller than 7. Then this will interchange its position. So now it will be 5, 3, 7, 2 and 8. Again this will change the position here. So it will be 5, 3, 2, 7 and 8. Now it will not change this position because I already have the largest element at the last of my list. So this is how you can see here that here I was having 1, 2, 3 and 4 comparisons. Here I am going to have 1, 2 and 3 comparisons. So in the same, first I was having the 4 comparison, then I was having the 3, then 2, then 1. So we can see here that I am having the 5 elements, so I am going to have the 4 comparisons. So for n elements I am going to have n minus 1 comparisons. And you can see here that we were having swaps also. So in the first case the swap was 4, then in 3, then 2, then 1. So we are also going to see that the swap will be something like n minus 1, then something, and then 3 plus 2 plus 1 swaps. So we can see after analyzing this, we can see that if we are always telling that number of comparison is going to tell us about the time complexity. So this is something like the sum of the first n natural numbers. So it will be n into n minus 1 by 2. So it will be somewhere around O of n square. So we can see that the bubble sort time complexity is O of n square, because this is not the index based sorting. This is something which we call as element based sorting, because here you can see that we are comparing the elements. So let me erase the extra which I have written here. Yeah, so you can see here that once we have done our comparison, now my list will be sorted in the order 2, 3, 5, 7 and 8. This will be my output. So let's write its algorithm first. So how we can do that? So first we need to write its algorithm, and then we are going to so writing algorithm for the bubble sort. So I will write here void, and then I will keep the name as bubble, and then after that I will have array as an input and then size of it. So first loop which I need to run is for the number of passes, int I is equal to 0, I less than n, and then I plus plus. Now I am going to have the second loop which is going to tell me that for the comparison. So I'll write here for I int j is equal to 0, j less than n, and then j plus plus. J n minus 1 we will be doing, because what we are going to do, we are going to see here that after each pass my number of comparison is being decreased. So if I'm going to show you my live coding window, so I'll be opening it along with my live coding. So yeah, you can see here that, my code that we have started with I is equal to 0, I less than n, I plus plus, and for this what I have done, I less than equal to n minus 1 minus I. So why I have done minus I here? Because after each comparison we have seen that I was not required to check with the last element, because at the last I'm already getting the highest element of that pass. So for this what I have done, what we were doing, we were comparing the a of j with the a of j plus 1. Like if we are comparing a of j, that is 8, and then comparing a of j plus 1, that is 5, and if a of j was greater than a of j plus 1, then what we were doing, we were actually swapping the number. So for that, what I have done, I have defined a function swap element, and then I have passed them as an reference, as an address here, because if you are not going to pass here as an address, so I cannot make the changes inside the array. And then you have seen here that we are initializing here the flag. So I'll tell you that why I have initialized here flag. So this is how my algorithm works. So if again enlarging my screen, you can see here that I have started with j is equal to 0, j less than n minus 1 minus I. This is done to decrease the number of comparison after each pass, and our this for loop is for the passes that I is equal to 0, I less than n, and I plus plus. And then if this condition is satisfied, like at the present position, and the position just adjacent to is it is greater, is having the greater element, so I'm swapping that number, and then I have defined here flag. So I'm telling you why I have defined here flag, and then I have displayed it. So now running the code here, taking the size as 5, and then taking the element as 4, 3, 2, 8, and then after that 7. So you can see here that the list sorted, and my sorted order is 2, 3, 4, 7, and 8. Now you would be thinking that why I have taken their flag. So for example, if I am already having a sorted list that is 1, 2, 3, 4, and 5. So if I am not going to take here flag, so for at least once this code is going to run. So let me show you with the live coding window. So yeah, this is my list which I need to sort, but I can see here that it is already sorted. So coming to the algorithm, so first of all, it will start for I is equal to j, I less than n, and I plus plus. So what it will do, it will start comparing. Okay, a of so it will first compare this one, a of j is greater than a of j plus 1, no. Then it will again shift it to the next one, then again 3, then this will again shift. First it will check for this one, the condition is not satisfied. Again it will check for this one, the condition is not satisfied. Again it will check for this one, it is not satisfied. Again it will check for this one. So what we can see here, that it runs at least O of n times. Why? Because my compiler is not knowing that the list which I have entered here is already sorted. So to remove this problem, that it must not go beyond this. So what we can do here, that we have defined here flag. So for that, what we have done, we have already initialized its value to 0, and then it is coming inside this loop and it is checking here. And if my list is already sorted, so this else if condition is not going to be executed and my flag value will not be changed. So if my flag value is not changed, means we are already having the list in the sorted order. So for that reason only I have defined a flag, so that in the case my list is already sorted, it must not go for the iteration once again. So this makes our bubble sort adaptive. So you can see here one interview question, that is the bubble sort is an adaptive in nature. So no, we are making it adaptive by defining a flag. And then we have checked that if flag is equal to 0, the list is already sorted, and you need to come out of this loop, the outer loop, because we are not required to check for the another pass. So now if I am going to run the code here and entering the value to be 5, and then entering here 1, 2, 3, 4, and 5. So you can see here that the list is already sorted 1, 2, 3, 4, and 5. यहाँ पे ऐसा इसलिए हो रहा होगा क्योंकि ये यहाँ पे चेक हो रही होगी वैल्यू, लेकिन चूंकि फ्लैग की वैल्यू 0 से 1 नहीं हुई, मीन्स हमारी लिस्ट जो थी वो ऑलरेडी सॉर्टेड थी. That's why what we have done, we have come out of the loop and we have directly checked the value, that if flags is equal to 0, you need to directly break out of the outer loop, that is this for loop, and we are going to call the display function. So with the help of the flag, we are going to make this bubble sort adaptive algorithm. Now talking about the stability of of the sorting technique. So for example, I am going to have 8, and then 8 and then 5, 7, 3 and 2. So we say that no duplicates element must be found, but for example this is 2 duplicate element and I'm keeping its name as 81 and this as 82. I'm just giving its name. So whenever we are performing the swapping, so this order is maintained in the bubble sort. So if we are going to have the output, we will have the outputs at 2, 3, 5, 7, then 8 having numbering as 1 and 8 having numbering as 2 will be maintained. Means the order of the values are being maintained. For example, we have the list of the students and we have here A, B and C. A is having number 4, B is having number 6 and C is also having number 6. So let me change here. A is having 6, B is also having 6 and C is also having 4. So this is already sorted on the basis of name, but now I want to sort it on the basis of marks, but I want that this order must be maintained. So this will be maintained in the case of the bubble sort. That's why we are telling that our bubble sort algorithm is an stable algorithm. So this was all about the bubble sort. तो यहाँ पे swap element आपने देखा, हमने यहाँ पे pointer as a pass किया. क्यों? क्योंकि हमें उस डायरेक्ट उस पोजीशन पे वैल्यूज को स्वैप करनी है. सो फॉर दैट वी हैव यूज्ड द call by address here, concept of the function calling. So this is how our bubble sort algorithm works. So this was all about the bubble sort. If in case you have not understood, then once again I am repeating what we have done here. First we have defined a loop for the number of passes, then we have defined here int flag equal to 0 to make our algorithm an adaptive one. Then we have defined the inner loop, which is going to compare the element, the adjacent element, and then swapping them according to the condition, that if this condition is being met, so we will have the swapping of the element and then flag value will be equal to 1. And then we have checked that if flag was not equal to 0 means the swapping took place. So in that case we'll have once again then passes, and then once our whole sorting is done, so flag value will not be changed because every time we are initializing the flag to 0, and in that case the loop it will come out of the loop using the break keyword and will display the list. So this is how the bubble sort algorithm works. I request you to please go along with it once again so that you can understand it better. Till then, keep enjoying, keep coding, take care and bye bye.
Congratulations on completing this concept. We will get back to you with some more interesting concepts in the upcoming video. Till then, take care and bye bye.